When we measure angles in radians, degrees, or revolutions, we need to also be able to convert between these units of measurement. We'll begin by considering how many radians are in one revolution of a circle. We know that the circumference of a circle is 2 pi r, so the circumference of this circle will let it be c, measuring the entire distance around the outside of the circle. We know that that entire distance is 2 pi r as per the circumference formula. Another way to consider the distance around the outside of a circle is by considering the arc length. So let's consider the arc length around the entire circle. If we were looking at the entire circle, that would also be the circumference. So if the arc length around the entire circle is the circumference, then we can set our circumference equal to the arc length formula. But remember, the angle in our arc length formula is measured in radians, so this angle is measured in radians. And it represents the angle that must be swept through in order so that the arc length is equal to the entire circumference of the circle. So now all we really need to do is to simplify this. We'll divide both sides by r so that the r's cancel out entirely, and we have solved for theta, where our angle theta is 2 pi. And 2 pi is an angle measured in radians. Again, angles in radians don't carry units, so we would just say there are 2 pi radians in one revolution of this circle. So to get all the way around a circle, we must sweep through an angle of 2 pi radians. But we also know that an angle of 360 measured in degrees would get us all the way around the outside of a circle. So because these two angles are equal to each other, we can consider the angle 2 pi radians in ratio to the angle of 360 degrees to be a well-chosen one. Since these angles have the same measure, their ratio is equal to 1. We could then simplify this ratio by canceling out the common factor of 2 to reduce this fraction and get pi divided by 180, which is another version of this well-chosen one, and one that's used far more often. Now, since these angles are the same, we could call it 2 pi over 360 degrees, or we could call it 360 degrees divided by 2 pi. Both of those are the same thing. And similarly, if we were to reduce this simplified version of our well-chosen one, we could get 180 divided by pi. Again, both of these ratios are equal to 1 because these angles sweep out the same measure. Here's a chart with some well-chosen ones that are commonly used when we convert between radians, degrees, and revolutions. In order to go one complete revolution, our angle measured in radians is 2 pi. So since there are 2 pi radians in one revolution, the measure of those two quantities is the same, and this ratio is equal to 1. But if we flip the numerator and the denominator here, we get another version of this ratio that's still equal to 1. If we were going to measure this angle in degrees going all the way around the circle, we would need 360 degrees. So if we move through an angle of 360 degrees, we get one complete revolution of the circle. And if we take these quantities in ratio, that ratio is equal to 1. Again, if we switch the numerator and the denominator, the measure of those quantities are still the same and their ratio is still equal to 1. Now, if there are 2 pi radians in one complete circle, then there's only 1 pi radians in half a circle. If we measure that in degrees, that would be 180 degrees, which is half of 360. So 1 pi radians is the same measure as 180 degrees. So if we take those two quantities in ratio, we get a ratio that's equal to 1. Again, if we flip the numerator and the denominator, the top and the bottom still have the same measure, and we get another version of a well-chosen one.